Hello, Matthews Gatos here. In this video, we're going to prove what the derivative natural log absolute value of x is. So let's get started. So if I have f of x is equal to natural log absolute value of x. So first thing I notice is this is a piecewise function because of that absolute value. So I need to rewrite this as a piecewise function. So normally when we take the natural log of x, that argument can be only positive. Putting the absolute value opens it up to being negative. Now, I still can't take the absolute value of, the natural log of 0. So in this case here, x could be greater than 0 or x could be less than 0 because of those absolute values, but x for sure cannot equal to 0. So let's look at the piecewise function. Natural log absolute value of x. That could be the natural log of x when x is greater than 0, or it could be the natural log of negative x, and that would happen when x is less than 0. So let's look at each case for this. So in my first case, I'm going to have y equals to natural log of x, and that happens when x greater than 0. My second case is to be natural log of negative x, and that happens when x is less than 0. So in this first one here, I already proved this to you in our last video. So I already know what y prime is. So in our last video, I proved to you that the derivative of natural log of x is 1 over x when x is greater than 0. So in this case here, I know y prime is equal to 1 over x. And that happens again when x is greater than 0. Let's look at our second case. So y is equal to natural log of negative x. So I'm going to write this before I take the derivative. I'm going to kind of play around with my function a little bit. I'm going to write it as log base e of negative x because natural logs are logs with a base of Euler's number e. I'm going to switch that into exponential form. So starting with my base stays the same, x and y interchange. So I do this big circle of logs. So e to the y is equal to negative x. Let me try that again. Is equal to negative x. Okay, so now that I have it in exponential form, I'm going to take the derivative with respect to x. So in a previous video, I've already proved to you that the derivative of e to the x is e to the x, but see, this is not an x. So anytime your exponent is something other than x, we're going to have to use chain rule. So this is what my chain rule is going to look like. The derivative of e to the anything other than x, e to the u, is itself e to the u multiplied by the derivative of the exponent. So this is going to be e to the y multiplied by the derivative of the exponent y prime is equal to derivative of negative x is negative 1. So if I want to get y prime, solve for y prime, I'm going to divide both sides by e to the y. So that's gone. So I get y prime equals negative 1 over e to the y. But remember, we said that e to the y was the same as negative x. So that's negative 1 over negative x. And two negatives make a positive, and negative 1 divided by negative x is 1 over x. But this case happens when x is less than 0. So we see the positive case, 1 over x when x is greater than 0. The negative case, also 1 over x, but when x is less than 0. So let's put that all together. So what we've done is we've proved that the derivative of natural log of x is 1 over x. When x is positive or negative, it can be anything except for 0, again, because I cannot take the natural log of 0. That would be undefined. So derivative of natural log absolute value of x, 1 over x, where x cannot equal to 0. Now that we've proved it, we can use it for all questions that follow, and we can also use it for future proofs as well. So if you liked this video and it helped, please give it a thumbs up and hit subscribe so I can help more mathies just like you. Thanks for watching, and we'll see you for the next one.